Let's now talk about the binomial distribution. If we repeat the same experiment many times and we divide the possible outcomes in just two groups, two sets, which we call success and failure, we can use the word trial. For example, to be or not to be? That is the question. William Shakespeare, Hamlet. The binomial distribution is characterized by the following features. The experiment is made up of many identical trials. For example, I toss a coin 1,000 times, 100 times, 1,000,000 times, 6 times, but all the tosses are obviously identical. There are just two possible outcomes, success and failure. Now, I can call head success and tail failure for a coin. Or I can roll a die, and if I'm interested only in sixes, sixes will be my success and all the other numbers will be my failure. Both outcomes have fixed probabilities. The probability of success is usually called P, that of failure Q, with obviously P plus Q equal to 1. If I toss a coin, then the probability of head is obviously 1/2, 0.5. The probability of failure is the same. If I'm interested only in sixes, as I said before, the probability of success is 1/6. The probability of failure is 5/6. The probability of success, that's a very important point, in any trial is independent of the outcomes of the previous trials. If I toss a coin 1,000 times, well, the probability of head or tail doesn't change. If I roll a die, probability of 6 or probability of any other number doesn't change, even if I roll it 1,000,000 times. The binomial distribution deals with the following question then. Given the number of trials n, what is the possible number of successes? If I toss a coin 10 times, what is the probability of having 3 tails, for example? If I roll a die 6 times, what is the probability of having 4 sixes? The binomial distribution is usually written as B for binomial, n, number of trials, P, probability of success. If we denote the number of successes with R, the general formula is then P of x equals R is equal to C n R, P to the R, Q to the n minus R, where C n R, which can be written also in this other way, is the binomial coefficient. Exercise. A typist has a probability 0.99 of typing a letter correctly. He makes his mistakes at random. He types a sentence of 200 letters. What is the probability that he makes exactly one mistake? Let me give you the solution, but I hope you have thought about that. From the above formula, we find that P of x equals 199 is the binomial coefficient of 200 and 199 times 0.99 to the 199 times 0.01, which gives 0.27. Now, an exercise without solution. 3 coins are tossed. What is the probability of all 3 of them showing heads? 2 heads and 1 tail, 1 head and 2 tails, all 3 showing tails. Please do this exercise by yourselves. Expectation and variance of the binomial distribution. From the definition of the binomial distribution, we find the following properties. The expected value, the mean, mu, is equal to n times p. Obviously, if you toss a coin 1,000 times, you expect roughly 500 heads. If you roll a die 600 times, you expect roughly 100 sixes. The variance, sigma squared, is equal to n times p times q, so np times 1 minus p, because q is 1 minus p. And the standard deviation is nothing but the square root of this number.